Hello, this is Abhijit Mukherjee. Today I am going to teach you Class 7 Science, Physical and Chemical Changes. Physical changes are the changes in which no new substances are formed. For example, the formation of ice from water kept in a freezer is a physical change because the ice, when kept in open, changes back to water. In most of the physical changes, properties such as color, shape, size, or physical form of the substance may change. Physical changes may or may not be reversible. An example of physical changes discussed here. Crystallization. Crystals are the purest solid form of a substance having a definite geometrical shape. The process by which an impure compound is converted into a crystal is crystallization. This process is used in obtaining common salt from seawater. Let us take common salt, which is an example. Chemically, common salt or table salt is sodium chloride, that is NaCl. Common salt is obtained by evaporating seawater. The salt thus obtained contains certain undesirable substances such as magnesium chloride, sand, etc., mixed with sodium chloride. These impurities are removed from common salt through the process of crystallization. In crystallization, maximum amount of common salt is dissolved in boiling water. The solution is then filtered to remove the insoluble impurities. The filtered solution is left undisturbed for a few hours. Sodium chloride will aggregate and form crystals with well-defined geometrical shapes, leaving behind the undesirable impurities in the solution. Let us perform an activity with the aim to prepare crystals of copper sulfate from a sample of copper sulfate. Materials required: a beaker, distilled water, powdered copper sulfate, stirrer, and dilute sulfuric acid. The method: first step, to take a beaker and fill it half with distilled water. Now to keep on adding powdered copper sulfate into the water with constant stirring till no more of it dissolves. Step 2, add half a test tube of sulfuric acid to it. Step 3, start heating and again add copper sulfate till a saturated solution is produced. Step 4, filter the hot solution immediately to remove insoluble impurities and keep the saturated solution of copper sulfate undisturbed for a few hours. Observation: well-shaped crystals of copper sulfate are formed. Chemical changes. A chemical change, also called chemical reaction, occurs when two or more chemical substances react to produce a new substance or substances with a different set of properties. A chemical change is permanent, and such changes are occurring all around us, even within our body. Let us look at some examples of chemical changes. Reddish-brown deposition on iron objects. You must have seen that you leave an iron object such as a trowel, that is kurpi, or an iron lock out in the rain. A reddish brown layer is deposited on its surface after a few days. This layer is called rust, and the process is called rusting. The layer of rust falls off gradually, exposing fresh metal to further rusting. With the passage of time, the iron object becomes weak. Let us see what actually happens. Iron reacts with atmospheric oxygen in the presence of moisture to form a substance called iron oxide, which we call rust. So iron plus oxygen plus water giving iron oxide. The chemical equation for this reaction can be represented as Fe plus O2 plus H2O arrow Fe2O3 dot XH2O. Rusting is a chemical change because the change is permanent. You cannot get the iron back from the oxide. Oxygen and water are two essential conditions for rusting of iron. Absence of either or both of them can prevent rusting. Oiling iron objects protects their surfaces from coming in contact with the moisture in air and therefore prevents rusting. Technological specifications. Galvanization is a process in which iron objects are coated with zinc to prevent them from rusting. Water pipes used in our homes carry water are made from galvanization of iron. Let us perform an activity with the aim to show that rusting of iron requires both oxygen as well as water. The materials required: 3 wide mounted test tubes, iron nails, boiled water, tap water, anhydrous, that is moisture free calcium chloride, vegetable oil, and rubber stoppers. Method: Step 1. Take 3 test tubes and label them 1, 2, 3 and place a clean iron nail in each of them. Number 2. Add a little anhydrous calcium chloride, that is dehydrating agent, to dry the air in test tube 1. Number 3. Pour boiled and distilled water to test tube 2 and add some vegetable oil to it to keep out the air. Chlorine in the water removes dissolved oxygen. Step 4. In test tube 3, pour a small amount of tap water. 5. Plug the mouths of all the 3 test tubes using rubber stoppers. Keep them undisturbed for 3 or 4 days. Observation. The nails in test tube 1 and 2 have not rusted, while the one in the test tube 3 has rusted. Conclusion. As test tubes 1 and 2 did not have moisture and oxygen respectively, there was no rusting in both these test tubes. This proves that both oxygen and water are essential for rusting. Browning of vegetables and fruit surfaces. If you observe the cut surfaces of a brinjal which have been exposed to air for some time, you will find that the surfaces have turned brown. This is due to the chemical reaction between certain compounds present in brinjal and the atmospheric oxygen. As a result of these reactions, a brown pigment called melanin is produced that causes browning of the surfaces. Soaking cut vegetables and fruits in plain water can reduce the level of browning. Water would restrict the amount of oxygen that comes in contact with the surface to cut vegetables and fruits. Reaction between vinegar and baking soda. Dissolve 1 teaspoonful of baking soda powder in 100 ml of water in a beaker. Stir the mixture until all the baking soda has dissolved. Measure out 5 ml of vinegar in a separate test tube. Use a dropper to add 5 drops of the baking soda solution to the test tube containing vinegar. In figure 4.5, where you can see that bubble coming out of the test tube. The reaction can be represented as vinegar, that is CH3COOH, that is acetic acid also called, plus baking soda, which is NaHCO3, which is also called sodium hydrogen carbonate, arrow, carbon dioxide, that is CO2, arrow given on the top because it is a gas escaping, plus water, that is H2O, plus sodium acetate, that is CH3COONA. We can test this gas that is released and find that it is carbon dioxide. Freshly prepared lime water turns milky when carbon dioxide is passed through it. This is a test for carbon dioxide. This reaction is also a chemical change and can be represented as carbon dioxide, CO2, plus lime water, that is CaOH whole twice, also called calcium hydroxide, arrow, calcium carbonate, CaCO3, plus H2O water. Reaction between copper sulfate solution and iron nails. Copper sulfate, that is CuSO4 solution, is blue and acquires a sea green color when iron nails are dropped into it. The iron nails acquire a brown color. This is because iron sulfate is formed when copper sulfate reacts with iron. Iron sulfate solution is sea green in color. A brown color deposit on the iron nails of copper. The reaction can be represented as copper sulfate, that is CuSO4, plus iron, that is Fe, arrow, iron sulfate, that is FeSO4, plus Cu, that is copper. Let us do an activity with the aim to study the deposition of copper from a salt solution. Materials required would be 3 test tubes, copper sulfate, water beaker, zinc metal, magnesium ribbon, and iron filings. Method 1. Prepare an aqueous solution, in water of copper sulfate in 250 ml beaker. Number 2. Take 3 test tubes and label them as 1, 2, and 3. Number 3. Pour 10 ml of copper sulfate solution in each of them. Number 4. Drop a piece of zinc metal, a magnesium ribbon, and some iron filings in the 3 test tubes respectively. Observation. You will observe that the blue color of the solution is gradually disappear and ultimately become transparent in case of zinc and magnesium, whereas it will form sea green in case of iron. Metals in each case will be coated with a reddish brown color. Conclusion. The solution turns transparent in case of zinc and magnesium due to the formation of zinc sulfate and magnesium sulfate respectively. As iron turns into iron sulfate, the solution turns sea green. Reddish coating of the metal is due to the deposition of copper metal. Now we are going to solve the exercise of page 63, chapter 4. We are going to solve the questions. Number 1. Which of the following cannot be broken down into simpler substances by chemical means? This is element. What is the chemical symbol of iron? That is option C, Fe. Number 3. Which of the following represents the chemical formula of a compound? That is CO2, option D. Number 4. What are the new substances, elements, or compounds formed in a chemical reaction called? That is option D, reactants. Number 5. What is the substance responsible for the browning of cut surface of vegetables and fruits called? Option B, melanin. Number 6. Which of the following elements exist as tetraatomic molecules? It is option D, phosphorus. Number 7. What is the chemical formula of sodium oxide? That is option B, Na2O. Number 8. Which gas is released in reaction with vinegar with baking soda? Option C, carbon dioxide. Number 9. Which of the following elements exhibit valency 2? That is option A, oxygen. 10. Which of the following represent an element? That is option B, chlorine, Cl2. If you remember, we have already solved the previous questions in previous classes, so I am solving the remaining questions. That is part 3, short answer type question. Question 4. Why do the cut surface of fruits and vegetables turn brown? The answer is this is due to the chemicals reaction between the certain compounds present in brinjal and atmospheric oxygen, forming a brown pigment called melanin. AbLaNin. Question 4. Complete the following word equations. Give their balanced chemical equations also. A. Magnesium plus oxygen giving magnesium oxide. 2Mg plus O2 arrow 2MgO. Number B. Iron plus oxygen plus water giving ferric 3 oxide, that is 4Fe plus 3O2 plus 2x of H2O giving 2 of Fe2O3 dot XH2O. One is vinegar plus baking soda giving carbon dioxide plus water plus sodium acetate, that is CH3COOH plus NaHCO3 arrow CO2 plus H2O plus CH3COONA. The next one is carbon dioxide plus lime water giving calcium carbonate plus water, that is CO2 plus CaOH whole twice arrow CaCO3 plus H2O. Next one is copper sulfate plus iron giving iron sulfate plus copper, that is CuSO4 plus Fe arrow FeSO4 plus Cu. So all these questions are solved in this chapter. This chapter is completed, and thank you very much. Bye.